Assalamu alaikum. My name is Khalid Muhammad and today I will talk about wave behavior. Let's examine what happens when a wave travels from one medium to another. In this figure shows a wave pulse traveling from a larger spring into a smaller one. The pulse that strikes the boundary is called the incident wave, which is this one. One pulse from the larger spring continues in the smaller spring, but the speed is different in the smaller spring. Note that transmitted wave pulse remains upward. Some of the energy of the incident wave pulse is reflected backward into the larger spring. This rotating wave is called the reflected wave. Whether the reflected wave is upright or inverted depends on the characteristics of the two springs. For example, if the waves in the smaller spring have a great speed because the spring is stiffer, then the reflected will be inverted. When a wave pulse hits a rigged boundary, the energy is reflected back as shown in this figure. The wall is the boundary of a new medium through which the wave attempts to pass. Instead of passing through, the pulse is reflected from the wall with almost exactly the same amplitude as the pulse of the incident wave. Thus, almost all the wave's energy is reflected back. Very little energy is transmitted into the wall. Also note the pulse is inverted. Suppose a pulse traveling along a spring meets a reflected pulse that is coming back from a boundary, as shown in this figure. In this case, two waves exist in the same place in the medium at the same time. Each wave affects the medium independently. The principle of superposition states that displacement of a medium caused by two or more waves in the algebraic sum of the displacements caused by the individual waves. In other words, two or more waves can combine to form a new wave. If the waves move in the same medium, they can cancel or add or subtract to form a new wave of lesser or greater amplitude. They emerge unaffected by each other. The result of superposition of two or more waves is called interference. Wave interference can be either constructive or destructive. The first panel in this figure shows the superposition of waves with equal but opposite displacements, causing destructive interference. When the poles meet and are in the same location, the displacement in point N, which does not move at all, is called a node. The pulses travel horizontally and eventually emerge unaffected by each other. Constructive interference occurs when wave displacements are in the same direction. The result is a wave that has an amplitude greater than those of the individual waves. A larger pulse appears at point A. When two waves meet, point A has the largest displacement and it's called the antinode. The two pulses pass through each other without changing their shapes or sizes, even if the pulses have an unequal amplitude. The resultant pulse at the overlap is still the algebraic sum of the two pulses, as shown as the final figure.